the second part of integration of parts, we'll be going over what happens if you were to use integration of parts multiple times. So in our example 1, we have integral of 3x squared times cosine of x dx. This integral requires integration of parts. As you can see, it's 3x squared times cosine of x. Using the acronym that we learned later, we could see that 3x squared is your u, cosine is your dv. So given that cosine is dv, we could say that v is equal to sine of x and du is equal to 6x. Keeping my integration of parts was u times v minus integral of v du. So integral of 3x squared cosine of x dx is equal to 3x squared times sine of x minus integral of v du. V in this case was sine, du is 6x, so 6x sine of x dx. So when we try to integrate this second part of integration by parts, we could see that we will need another integration by parts. So this is what I mean by repeating uses of it. Before we use integration by parts, I'm going to factor out a 6 since that's a constant, so that will be a little easier to work with. So let's do integral of x times sine of x over here in the right. Once again, your x is u, your sine is dv. So u is equal to x, du is equal to 1, dv is equal to sine. Therefore, v has to be negative cosine. So we could say that u times v, so negative x times cosine minus integral of v du, so that would be positive because double negative of cosine. So let's substitute it back in replacement, since we know that x times sine of x, integral of that will equal to this. Now, let's distribute and integrate this cosine. We'll have our answer. So I'm going to start with distribution first. We'll have positive 6x cosine of x minus 6 times integral of cosine of x dx. So our answer will come out to be 3x squared times sine of x plus 6x cosine of x minus 6 sine of x plus c will be our answer. So notice that in this example, we have to use integration by part twice. There are cases where you have to use more than twice. It could be 3, 4, 5. So therefore, there is a quicker way of doing it. That's known as a tabular method. Let's use the same equation to solve using the tabular method to compare the answers. Again, tabular method means that we'll have a table. So I created a table. We already know the answer to the integral of 3x squared times cosine of x since we just solved it out. So the answer should come out to be 3x squared times sine of x plus 6x cosine of x minus 6 times sine of x plus c. So the whole idea behind tabular method is to organize your u and dv. So the second column is your u. Third column will be your dv. When you're given u, you have to take the derivative. So we're going to take derivative until you get to 0. Derivative of 3x squared is 6x. Derivative of 6x is 6. And derivative of 6 is 0. Now for dv, we're going to integrate it because we need to find b. Integral of cosine is sine. Integral of sine is negative cosine. And then negative sine will be the integral of negative cosine. Now the first column is your sine. In fact, it's alternating the sign, so you'll start with positive all the time, and you're gonna alternate. And the idea behind that is from integration by parts is uv, technically positive uv, right? Minus integral of v du. Notice that it'll be positive and negative. If you were to have another one, integration by part, you'll have positive and negative. So negative times negative will be positive. That's why it's alternating over and over and over and over. Now, once you have this chart filled out, all you have to do is put them together to get our answer. And it's following the concept of integration by parts, u times v. So here's your u. Again, integral of dv was v. So it'll be organized this way, u times v. So across and diagonal, across and diagonal. So we have positive times 3x squared times sine. So the first term will be 3x squared times sine of x. Second term we have is negative times 6x times negative cosine. So double negative means positive. So we have positive 6x times cosine of x. And the last term is positive times 6 times negative sine. So it would be negative 6 sine of x. And then don't forget plus c. Notice that they're exactly the same. Even if you have to use multiple times, whether it's 2 or 3 or 4 times for the integration of parts, if you use tabular method, it will quicken the process. So when to use tabular method? There are 3 scenarios where you have to use it. The idea behind the tabular method is to organize using a pattern. The pattern is when the integral becomes repetitive. So like sine and cosine, they're going back and forth, rotating back and forth. Exponential function is another one of those cases, e of x to e of x, back and forth. So there are 3 cases. When you have algebraic times sine of x, algebraic times cosine of x, algebraic times e to dx, and these 3 scenarios we will use tabular method to solve for integration of parts. Now next example, integral of e to the 2x times cosine of 3x. So starting off with our u in this case is cosine of 3x, because trigonometry function come before exponential. So dv in this case will be e to the 2x. Therefore v has to be 1/2 of e to the 2x. And du has to be negative 3 times sine of 3x. So let's see. Integral of e to the 2x times cosine of 3x will equal to 1/2 e to the 2x times cosine of 3x minus negative 3 over 2 e to the 2x times sine of 3x dx. Again, I'm going to factor out negative 3 over 2x to make it easier to solve. So we have positive 3 over 2 integral of e to the 2x times sine of 3x dx. Once again, we have second integration of parts where your u in this case is sine of 3x. So therefore du has to be cosine of 3x times 3. dv is equal to e to the 2x. So v has to equal to 1/2 e to the 2x. So the integral of e to the 2x times sine of 3x will be one half e to 2x times sine of 3x minus integral of 1/2 e to the 2x times cosine of 3x times 3. So we're going to substitute this in replacement of that integral sign. So we have 1/2 e to the 2x sine of 3x minus, I'm factoring out 3 over 2, so 3 over 2 times integral of e to the 2x times cosine of 3x dx. Now let's get rid of the bracket by distributing these values in. So we could say that integral of e to the 2x cosine of 3x dx, which is what we're solving for, is equal to 1/2 of e to the 2x cosine of 3x plus 3 over 4 e to the 2x sine of 3x minus 9 over 4 integral of e to 2x cosine of 3x dx. We can try doing the integration by parts again here. Notice that it will repeat over and over and over and over because e to the x will go to e to the x, cosine will go to sine, back and forth. So what you should be recognizing here is integral of e to the 2x times cosine of 3x is what we're looking for. They're same term. So you could think it as this way. This term, if you call that an x, if I call this 9 over 4x, we could try to combine them together by adding 9/4 of x to the other side. And that's what we're going to try to do. So since these two terms are the same term, just don't forget this is 1, imaginary 1 there, right? We're going to add 9/4 of the integral of e to 2x cosine of 3x to the other side. So we should have 13 over 4 integral of e to the 2x cosine of 3x dx equal to 1/2 e to the 2x cosine of 3x plus 3 over 4 e to the 2x times sine of 3x plus c. Now our goal is to solve for one integral. We have 13 over 4 of them, so we're going to divide it to the other side. So 1 integral of e to the dx cosine of 3x dx will be 1/2 e to the 2x cosine of 3x plus 3 over 4 e to the 2x times sine of 3x plus c This whole thing will get multiplied by 4 over 13. So integral of 2x times cosine of 3x dx will equal to 2 over 13 e to the 2x cosine of 3x plus 3 over 13 e to the 2x sine of 3x plus c will be our final answer.